In this video we're going to talk about another example with integration by substitution, and the integral will be a definite integral. Okay, so we're going to have from -1 to +1 the limits of integration for the x variable. So it will be x over x squared plus 1 squared dx. So I'm going to choose a u variable as x squared plus 1, and the du is going to be 2x dx. Okay, so let's write this. So I'm not going to change the variables yet. So I'm just going to write 1 over x squared plus 1 squared times, and we have du as 2x dx. Okay, now notice there's a 2 there that didn't exist before, so we multiply the integral by 1/2 to satisfy the fact that there was no 2 there, right? So now let's talk about changing the limits of integration, because now we're entering a new variable which is going to be u instead of x, right? So when x is equal to -1, u is equal to -1 squared, which is 1, plus 1 is equal to 2. When x is equal to +1, u will be equal to the same thing, right? 1 plus 1 is equal to 2. Okay, so that's interesting, right? But basically, we're going to integrate from 2 to 2 for the u variable, right? So we're going to have 1 over u squared, so we can write it as u to the -2nd power du, all right? So then we're going to keep the 1/2, we're going to bracket, so as a result we're going to have 1 over u and then the negative coefficient, right? So 1 over u, so that's integrated from 2 to 2. Okay, and it should tell you that if you integrate from 2 to 2 you will get 0, right? So, but let's test that algebraically to see what we're going to get. So -1/2 minus -1/2, right? So that is equal to 1/2 times 0, which gives you 0. So we just proved it algebraically that indeed when the limits are the same, the upper and lower limits of integration, your integral will be 0. So hope you enjoyed this tutorial. Please subscribe and I'll see you in my next video.